In this video, we're going to continue our work on factoring polynomials, and we've been working with polynomials that have two terms, binomials, and special products. And today we're going to talk about two special products called the sum of two cubes and the difference of two cubes. The first thing I want to tell you is we got to recognize cubes when we see them. So you'll notice that in our first example here, we've got an x cubed. So that's a big hint, isn't it? So we need to just make sure that that 125 is a cube. And if you do not recognize perfect cubes, one thing you can do is go to your calculator and take a cube root of that 125 to see if it's a perfect cube. So let me show you that here in my calculator. So in my TI, I would go to the math menu, and there I would see that the fourth down is a cube root, and then I would type in my 125 and hit enter. And so now I know that 125 is 5 cubed. So now let's go back to our problem and use that fact to help us factor. So I'm back here at the first example, and I want you to know that I did check my two terms before I started for our GCF. Remember, we're training you to check for that automatically, and our GCF here is 1. We did count the terms. We know this is a binomial. And third, now we can see by the fact that we did take that cube root of 125, that we have here the sum. So the sum comes from that, right? And that we have the sum of x cubed and 5 cubed. And so we call that the sum of two cubes. And we want to keep that handy because now I'm going to teach you the technique for factoring sum of two cubes, and this is the technique that you're going to want to memorize or learn before your first assessment. So when we're factoring out sum of two cubes, we start out with writing down a small parentheses and then a larger one. In the small parentheses, we have a binomial, and in the larger parentheses, we're going to have a trinomial. Now in the binomial, the first thing I want you to know is that we're going to take the cube roots of both of those terms that we started out with. So what did we cube to get x cubed? We cubed an x. And what did we cube to get the 125? We cubed a 5. And in the binomial, the signs are going to match. So our binomial, it's composed of the cube roots of the original terms. Now we have to build a trinomial, so I want you to learn this pattern. The first term in the trinomial is this term squared. So you can square this first term in your binomial and you're going to write it here. So for that, that's x squared. The middle sign here that comes next, these are going to be opposites. The trinomial, that second term, has opposite sign of what the sign of the binomial has. So in this case, that's going to be a minus. The middle term here is going to be the product of the two terms in the binomial. So multiply the 5 and the x. So we put 5x. So this is a product. This next sign in the trinomial is always plus. Always plus. And then our last term in the trinomial is the 5 squared. So 25. Okay, so we want you to learn this pattern, and you'll see as we go through the different problems that we're using the pattern over and over again. Now, let's check this. Not necessarily going to check all of the problems in this particular video, but this does look kind of weird, doesn't it? That you have a binomial and a trinomial and that you're going to somehow multiply all these terms and end up with an answer that only has two terms. So let's go ahead and check this so that you can see that it really does work. Okay, so I went to a new page here. We've got our original problem and then our answer, and we're going to check it by distributing. First, we distribute the x throughout the trinomial, and then we're going to distribute the 5. So that's going to give us 6 terms. So we get x cubed minus 5x squared plus 25x. And then when we distribute the 5, we get 5x squared, and I'm going to line them up. I'm going to line up the like terms, minus 25x plus 125. And notice how these middle terms here, they give us 0. You see that? They're exact opposites. And so our answer for this product is the binomial we started out with. So that definitely checks. So in problem number 2, we are going to factor completely. We're going to look first for a GCF. In this case, the GCF is 1. We're going to count the number of terms. So you have a binomial we look at that x cubed and we think, this might be something, a binomial that deals with cubes. So looking at 216, using the calculator if you need to, we realize that that is 6 cubed. So we have x cubed minus 6 cubed, which means that we have a difference because of that subtraction sign in the middle of cubes. So the difference of cubes has the same pattern as the sum of cubes, in that you're going to start with parentheses for a binomial, followed by parentheses for a trinomial. And in the binomial, you're going to use the cube roots of your two original terms, so x, and you're going to keep the sign in the original problem, so x minus 6. Now, the pattern to build the trinomial is the same pattern that you learned with the sum of cubes, which is why I taught it to you as a pattern. We're going to square this first term, and that goes here, so that's x squared. So square here. We're going to use the opposite sign here, so that makes this a plus this time around. We're going to take the product of our two cube roots, so product, so that means 6 times x. So notice we don't deal with the sign there because you've already put the plus. You just multiply the two cube roots of your original problem, 6 times x. This sign will always be plus in both cases, always plus. And then for our last term in the trinomial, we need to square the 6. Square the 6, and that gives us 36. Taking a look at my binomial and trinomial, it cannot be factored further, so this is our final answer. And if we want to check, we know that we could just distribute and check the answer as I showed you in the last example. Let's do a couple more practice problems here. Okay, once again, now numbers are getting a little bit bigger here. However, 27 and 1,000 and also x's and y's, they have a GCF of 1. So we're at a GCF of 1. We're counting the number of terms in the polynomial. We are looking at binomial. So we have 2 terms. And given these cubes, it's a good chance that these are cubes, right? So 27 we know is 3 cubed. So we have 3 cubed x cubed here in your first term. And 1,000 is 10 cubed. So we have 10 cubed y cubed. So definitely we have difference because of the middle term, right? We have a difference of cubes, similar to the last one, right? So we're going to build it the same way. We're going to get a set of parentheses here going for the binomial, and then a set of parentheses here going for the trinomial. And in that binomial, we're going to take all these numbers and letters that we cubed to get the original problem. So that would be a 3 and an x, keep the sign, and a 10y for that second term. So the binomial you always build with cube roots and keep the sign, okay? Now, let's build the trinomial. So we're going to square this first term, and you have to square carefully. Okay, because oftentimes I'll have students that will write here 3x squared. No, no, no. We must square the 3 and the x. 9x squared. Okay, now if you think about it, that makes sense because this 3 and that 9 have to give us the original 27. So keep that in mind when you're doing these problems, okay? So square the variable and the coefficient. Okay, this sign here you know is the opposite. So this is a plus. Good. You know this middle term is product, the cube roots. So it's 3x times 10y. 3x times 10y is a 30xy. Okay, that's good. Now, this sign is always plus. This is always plus, right? And for that last term, we're going to square the 10y, taking special care to square both the 10 and the y. So that gives us 100 y squared, and that's kind of good because 10 times 100 is 1,000, right? Just a little kind of mental check. Now this binomial doesn't factor further, and neither does this trinomial, so this is our final answer. Are you starting to get the idea of how this pattern works? If you know the pattern really well, you can factor these pretty, it's very methodical, isn't it? Very methodical. Okay, I'm actually going to let you pause the video and try number 4. Okay, so give that a pause. Okay, here's my answer. See if it agrees with yours. We looked for a GCF, which it was 1. It's a binomial 2 terms. This time we have a sum of cubes. And we realize that 729 is 9 cubed, 343 is 7 cubed. So our binomial is 9a plus 7b. Then we squared the 9a to get 81a squared. We remember to square the 9 and the a both. How did you do with that? Good. And then opposite sign. So we have opposite sign here. Our middle term is the product of 9a times 7b, which is 63ab. And then this is always plus this next sign. And then we squared the 7b, which gave us 49b squared. I bet you did fine. Yes? Okay, I think we have one more. Take a look at this one. What do you notice? Probably saying it's not cubes. I see a y to the fourth. But maybe instead you're saying, I think there's a GCF. And you would be absolutely right. Okay? What we're headed towards is that in our next section, we're going to have all of these factoring problems that we've been working on. They're all going to be mixed up. And you will have no extra tools but your knowledge of factoring to get you through. And so these are the techniques that you want to look for. The first thing is, this is why I've been trying to train you, look for GCF first, even if they don't remind you, right? And the GCF here is a negative 3y, isn't it? So the first step is to factor out that negative 3y. Always that first step is going to be to look for that GCF. So that's going to leave us here a y cubed plus, and 3 divides into 192, 64. So we get negative 3y as a GCF and then a binomial in the parentheses. So that's my next step, is to recognize that I have two terms. So it's a binomial. We've got some binomial products that we've been learning. And that y cube gives a good clue as this being the sum of cubes, especially if you go cube root 64 and realize that that's 4 cubed. I got to give you a heads up about 64. It's both a perfect square, right? 8 squared, and it's also a perfect cube, 4 cubed. So you're going to see it in a lot of problems, okay? And you have to know whether to use it as a square or a cube. And in this case, we need to use this as a 4 cubed for that 64. Okay, so we're going to keep the negative 3y. Don't lose that. That tends to get lost. We're going to open our binomial parentheses and our trinomial parentheses. And now we're going to use our pattern that we've been working on, which means that in the binomial we have these y plus 4, because those are the cube roots of our two terms, right? And then we're going to build this trinomial by squaring the y, so that's y squared, using the opposite sign, which is a minus, multiplying the 4 times the y. This next sign is always plus, and then squaring the 4 to a 16. Okay, how did that go? Fabulous. You're doing great. Keep practicing.